Welcome to Preparing to Kanban, the second video of 4 giving examples on how to use Kanban for software development. Our previous video was Kanban, a fast food example. The following videos are Running Kanban and Managing Kanban. In Preparing to Kanban, we'll be detailing the software to be developed and building the Kanban board. That includes determining the steps, picking the numbers for limits, and determining the done conditions. We'll also cover what goes on a Kanban card and do the analysis that goes into making the cards for the backlog. This includes prioritization of requirements, identifying dependencies, and picking which cards go on the board and which wait. The second video, Running Kanban, will show the progress through the project and include the swim lanes for specialties, tracking delayed items, communicating with the customer for feedback, handling small changes and reprioritizing the backlog, with the ever-popular animations of cards moving across the board as the software is developed. In Managing Kanban, we'll look at using Kanban for software development from a project manager's perspective. We'll address risk, time and money budgeting, when to reallocate resources and adjust the limits on the Kanban board, and how to use a number of performance metrics. One of the ways people learn best is by seeing an example. Unfortunately, most of the software that's developed is proprietary, so real-world examples are hard to find. Here's an example of one of the better pictures we were able to find. It's not very informative to those who aren't familiar with the project. We can't even tell if this is software development or some other project. In these videos, we'll follow the process for developing a specific piece of software without actually writing it. Thus, we're free to give details. If the software sounds like a good idea, please feel free to develop it. Let's get started by meeting our development team. Here's our development team. Enrico Gonzalez, our project manager and team leader. Sarah Walters, our expert with the banner system. Yoshi Wu, our expert coder. And Michael Green, an intern and novice coder. The software we'll be developing in this example helps students register for classes at a university. We'll start out by making a wish list and then prioritize. We want students to be able to register for classes on a phone or tablet, to check their progress through major and general studies requirements, to see what classes are offered this semester that would fulfill their major or general studies requirements, to see what classes they need to take to graduate, to check grades from previous classes, and to see classes at other campuses. We also want advisors to be able to check student progress, approve or veto classes for the next semester. Course instructors should be able to waive prerequisites for their class, move students from the waitlist to the class roster, and allow students to take their class more than once. Let's slow it down a bit here. While wish lists are nice, not everything on a wish list can be incorporated into the software. Kanban starts out saving us time right away by having the customer prioritize right off the bat, so the developers only address things that will be in the software. Let's bring our stakeholders to a meeting with our team and ask them to do some prioritizing. Enrico says, "Let's get the necessities done first, then we can add the extra features." The features that are absolutely necessary, the must-haves, define what we call the minimum viable product. Without these features, the product is pointless. For example, an instructor being able to waive prerequisites for a class is nice, but it's not the root of what the program is there to do. Enabling a student to register by clicking on a link is central to what this program does, and the program would be pointless without it. Accepting the student's registration as part of the minimum viable product, where allowing the instructor to waive prerequisites is not. Using Kanban, we concern ourselves with the minimum viable product, the must-haves, before considering the should-haves, could-haves, and wants. Let's look at a use case for the minimum viable product. The minimum viable product use case goes like this. The student wants to register for the next semester. They go to the university's website on their tablet and authenticate. The system looks up the classes being offered next semester at the requested campus and the list of classes needed for the student's major. It checks which of the classes for the major are offered next semester and if the student has the prerequisites. Those classes are then suggested to the student. The student registers for these important classes, and then they search for a couple of additional classes to fill out their schedule. When they cook a class, the system checks to see if they have the prerequisites, and then lets the student know if this class is an option or not. The student makes their decisions, adding and dropping classes as needed. The student gets registered, and their advisor gets notified. The advisor sees that the student registered. They check the student's progress through the requirements and approve or veto the student's class list. The student then gets a message regarding the advisor's actions. So, what do we need to do to get this program to work as desired? Here's a list of the requirements for the MVP. We want to keep these at feature level at this point. We'll break them down into programming tasks during analysis. Now that we have an idea of the work and the team, let's start building the Kanban board. To do that, we determine what high-level steps we need all parts of the project to go through. Then we determine how much work can be done at each step and figure out what the done conditions are. Let's get started. The Kanban board can have any number of steps with any titles, depending on the project. Since we're writing software, let's look at the process needed to produce a program. First, we break things down into smaller pieces. Then we write the code and test the system and integration. Each of these steps, analysis, code, and test, will need an in progress and a done column on the Kanban board. Let's look at each of these steps closer. In the analysis step, we figure out how we can break things apart in reasonable sized chunks. What goes in a function, what objects are needed, etc. We want the chunks to be codable in a day or two. We may also discover that one or more subtasks have already been done. For example, when the student uses the interface, they'll sign in. The program will establish a link with banner, verify their credentials, acquire the student information, and acquire the university and class information. There may already be a function to get classes offered next semester, since that's something the current system already does. When possible, we want to reuse that code rather than reinvent the for loop. The code step is, obviously, where the code is written. For example, here's where our banner expert writes the code to take the data given by the student, identifies them in the system, and accesses the correct information. The most efficient way to code in Kanban is to use test-driven development, since that ensures the code will pass unit-level testing, and we don't write any more code than is necessary. Since all software, no matter how well managed, ends up with something on hold, we'll need a tracking column in the code section. That'll be the place where we put things that have been started but are waiting for something. Once the code is written, we need to test it. The testing consists of both integration and system testing. The testing column may or may not have a done column, depending on how the software is delivered. If it's delivered continuously, then there's no need for a done column. If it's delivered in installments, such as weekly or monthly releases, then a done column will tell us what needs to be implemented on the customer's system yet. Let's look at the Kanban board so far. Cards with parts from the MVP, minimum viable product, will go into the backlog. In the analysis section, those will be broken down into equal-sized chunks. Then those chunks will be coded, tested, and released to the customer. The board needs some work yet, though. Swim lanes can be added to the board when the team has somebody with a specialty, such as a familiarity with the banner system or an expert in cybersecurity. Adding a swim lane tells us at a glance how busy our expert is. Cards containing work where the specialist knowledge is necessary will go through their swim lane. Kanban limits the chaos in the development process by limiting the work in progress. How do we find those limits? When determining work in progress limits, there's some factors we have to keep in mind. Are the people on our team working on this project exclusively, or are they on multiple teams working on multiple projects? How many different steps in our project is each person covering? There are a lot of different ways to pick work in progress limits, but no official way. The first thing to realize is that no matter what method we pick, our starting limits will be wrong. How we adjust those limits will be covered in the third video, Managing Kanban. However, we have to start somewhere. Let's look at a couple methods to get ballpark numbers. One method is to take the number of people on the team and multiply by 3. In our case, we have 4 people, but one is a specialist and another is an intern. So let's make a range of 9 to 12. That gives us a total for all 3 steps. Another method is to multiply the number of developers by 2 to establish the work in progress through the coding section. Let's just count our 2 expert coders here and say 4. Another way is to count the number of people who can contribute at each step and subtract 1. Let's look at our team. The n-1 method will give us a 1 in analysis, a 3 in coding, and a 2 in testing. Finally, let's look at what a weighted sum will give us. We'll assume our team is only working on this project. We can determine the work in progress limits for each step by looking at the number of people capable of working at a task, how many tasks they have to perform, and their level of expertise. Even though she's working on all 3 steps, our expert coder is going to be a more productive coder than our intern. The question becomes, how much work could each person get done if their time was divided evenly among the steps? Our team leader and expert coder could probably do an analysis, a coding, and 2 testing jobs in a day or 2. Our banner expert isn't as quick at doing non-banner things, so we'll give her a 1/2 for coding and a 1 for testing. Our intern gets a 1/2 for coding because he's a beginner who goes slow and asks questions to be sure he gets things right. Adding them up for each step, we get starting numbers for our limits. We get a 2 for analysis, a 3 for coding, and a 5 for testing. Let's look at the numbers that these methods gave us. The developers times 2 gives us only the limit for the coding step. The n-1 is a little bit lower than the other 2. The weighted average and the team members times 3 seem to be in agreement. So let's start with the weighted average limits. Remember, these are just starting limits. Once we get working, we can see how well these limits work and adjust them when we get a bottleneck. Here's what our board looks like now. We have the steps, the work in progress limits, and the swim lane for our banner expert. This is the version we'll be using in this demonstration. How do we know when to move a card into the done column? Let's establish some done conditions. For analysis, we need to ask if the pieces we've broken things into can be done in a day or 2, if the task will fit together when done, and if all the task prerequisites are done. All the questions must be answered with a yes for the task to count as done. Here's some done conditions for coding. The first 2 are pretty clear-cut. Is the unit doing what it's supposed to, and does it pass the necessary tests? The third question, does the code meet organizational specifications, can refer to things like a requirement for internal code documentation, code formatting, or a standardized way of naming variables or organizing objects. Those should be listed in writing somewhere so that they can be checked by people new to the organization, such as our intern. In the testing step, the done conditions would require the code to be able to be integrated into a working test version of the program. The test program would need to perform correctly afterwards based on the test suite of possible data entries. Like the rest of Kanban, what goes on a Kanban card is minimal and flexible. Since Post-its are often used for Kanban cards, we don't have much space, so listing everything about that piece of work isn't going to be very helpful. Instead, we want to put as little as possible on the card. One of the tasks we'll need to do for this project is to build a website. We'll put that on a card. We don't need to say how we'll do it. We know there's going to be interaction with banner involved, but we don't have to write that. We just want the high-end view of what we're doing. If it needs to be broken down further, that'll happen in the analysis section. When the task is assigned, the person working on it will put their initials and the date on the card. That tells anybody looking at the board who is responsible for that piece of work and how long it's taking. If Yoshi catches the flu and is home for a week, Enrico can easily see what work needs to be shifted to other people on the team. If we're using Kanban as a project management tool, we'll want to put a rough estimate of the time this task will take on the card as well. Now we're just about ready to start. But which cards do we put on the board? We can't put everything on the board at once, or there will be no way to determine what should be worked on next. We need to set priorities. The cards in the backlog section should be as small as possible while still being at the feature level. We want to be able to talk to the customer about the progress of a specific feature, even though as developers we're already mentally changing some of these into programming tasks. Changing features to programming tasks should occur in the analysis section. Most of the features listed here are good. The only exception is the display results feature, which can be broken down into 2 sub-features, display class lists and display registration changes. Here's the cards we have to work with for the MVP features. We've renamed List of Classes Offered Next Semester Needed for Students Major to list applicable major classes so we can fit it on a card. Some of these features depend on other features being done first. For example, we can't display a list of classes if we don't have a website. Let's rearrange these cards to show dependencies. This will tell us what features need to be done first. Here we have the cards showing the dependencies. The cards on the left have to be done before the cards on the right. The lines show which features are dependent on which other features. Looks like we need to search for classes and build that website before anything else. In addition to the direct programming work, there's some off-the-board prep work to be done. Who will the customer contact be? How do we get test access to Banner? Will we be doing a continual release or periodic releases? A continual release means no done column on the Kanban board for the testing step, as modules that pass tests would immediately be implemented. A periodic release would mean we'd need the done column to tell us what was ready but had not yet been implemented. Even though we're starting out with only 9 cards, we only want to put the first 3 or 4 on the board. That makes it easier to read and reduces the stress on our development team. It looks like we're just about ready to run Kanban, so let's switch to the Running Kanban video. See you there.